So, good morning everybody. Nice to see so many people fresh-faced after the data night out, ready to look at lots and lots of code for the next hour. I'd like to thank you all for joining, making the effort to come today. Welcome to the session From Hello World to Saving the World, Advanced Analytics with Python. So my name's Rachel. I'm a solution consultant based in the London office, and that basically means I'm part of an account team that a lot of you will have, and my responsibility is more on the technical side, so helping customers get the most out of their Tableau deployment. The goals that I want you guys to keep in mind as we go through the session today, I want you to focus on two main things. So the first one is looking at how you can use Tableau within your data science process. So I see a lot of customers really excited about the possibility of bringing in external services into Tableau, but equally a lot of people struggle with it as well. So I want to show you how it can be really easy to integrate, and also show you some examples that hopefully should be exciting and inspire you a little bit as well. And the second thing we're going to look at is how can we do this at scale? How can we deploy this at scale to get more people across the organization involved in the conversation around data science? Because I think there's a great opportunity ahead of all of us. So at Tableau, we help people see and understand data. And if we extend this to the world of data science, helping people use powerful algorithms on their data is going to lead to much richer discussions all across the organization. Those are the two things to keep in mind, and that's what we're going to be focusing on. As for the flow of the session, what we're going to cover, I'm going to talk around why it might be helpful to use external services in the first place. Then I'm going to talk a little bit around what is it that I'm referring to when I talk around the data science flow or the data science process. Then we're going to have a little recap of how the integration works. So the focus of today's session isn't to go through that in too much detail, but I just want to make sure everyone's got the same base level knowledge before we jump into some examples. Then it's on to saving the world, which is quite ambitious in an hour, but I'm going to give it my best go, my best shot. And then finally, how can we scale this? How can we make this helpful for lots and lots of people? So essentially, we're going to start off with a bit of theory, jump into some practical examples, and then look at how that can scale across an organization. So why might we want to use external services with Tableau? So there's lots of talk in the industry around advanced analytics, and even if you think back to the keynote yesterday, we showed some really cool things coming with explained data and the Databricks connection that's coming in. And I personally think it is going to play a really big role in our future and provide insights like never before. And using external services with Tableau is just another way to tap into that opportunity and tap into that space. But first, I think it's important to define what I'm talking about when I talk about advanced analytics. So if we think about the different questions that we can ask in our business, typically what we will have started with is, okay, what happened? What happened last week? What were my sales? What profit did I get from these categories? And it's so very descriptive analytics, and even Excel's really great at giving us that information. Then we grow and start thinking about, okay, I want to know what's happening right now within my business, or what might happen in the future. So more diagnostic or prescriptive analytics. And Tableau's really great at this out of the box. We can iterate through, ask different questions, find out the unknown unknowns, things we didn't even know we wanted to know from our data by going through this process of visual analytics. But sometimes we want to ask more prescriptive questions. So what can be done to make a certain outcome happen? And this is when you might not start to need to look outside of what Tableau provides out of the box to assist you in answering those questions. And today we're talking about the Python integration with Tableau. So there's three different options if you want to connect to external services. One is Python, and to do that we use something called Tappi. You can also call out to R services or MATLAB as well. So today I'm focusing on Python just because that's all the code that I've got to show you. But the same concepts of what I'm showing can be applied if you're more comfortable coded in those languages as well. So what does Python bring to this party? Well, it's got lots and lots of statistical and machine learning algorithms, and the list of them is growing every day. It's contributed to by university projects, big companies like Google and Facebook, so the standard for these algorithms is set pretty high. It allows you to put into production certain machine learning algorithms. So think, for example, you could pre-build and train a model and run it on new data as it comes into your business. So things like fraud detection. You can look at fraud detection or looking at chance of customer churn. You can run that as the new data is brought into your business. And finally, it's a real programming language, so you have much more expressive power. You can write lists, loops, call out to web services, lots of things like that. So it really opens up the box of what you're able to do. Onto Tableau. So what does Tableau bring? Well, we have lots and lots of data connectors. I think over every time I do a demo, the number goes up. I think it's 70 native database connectors. And that means that we've worked with an end vendor to optimize the query that we're sending to the back end. We do a lot of query caching, query optimization, so you know the communication that's happening there is really optimized. You can explore at the speed of thought. So we can drill up, down, filter, partition our data, change the visualizations to answer different questions. And finally, interactive storytelling. So once you've got your insight and you want to share that with people across the business, you can build interactive dashboards, even story points, and guide the end user through your process of how you got to that end result. So I think it's a great match when you bring the two together. As I mentioned, the way in which we run Python within Tableau is using something called Tappi. So that's been available in Tableau since 10.2. And if you want to find more information on that, that's all listed up on GitHub, so our website that's built for developers to share code and projects. So there's lots of information on GitHub around Tappi. It's open source, just like Python, but it's owned by Tableau, which means we can push updates to it and optimize things really easily. OK, so the data science flow. What am I talking around when I talk about the data science flow? As with any analytics, we start with a question. To answer that question, we need some data. And this is the flow that most Tableau users will be really comfortable with. We get our data, it's usually messy, it needs reshaping, it needs to be processed, and then we can start exploring, looking for insights within the data. And this is an iterative process in itself. Once we find insight, it might give us more questions that we need more data, and it pushes us around in this loop. But sometimes we get to questions that can't be answered visually. And then we have to look at different models to do that. So think about questions around, you might want to predict a quantity and use a regression model for that. You might want to predict a category and look at classification. Or maybe group certain behaviors together through clustering algorithms, or improve data structure with dimensionality. So to do this, we can't take our data set as an entirety. We then have to split that up into train and test. Because when we're working with models, if we test the model on the same data it's trained on, it creates bias because it already knows the answer to the question. It's like seeing your exam before you take it. So running it on an entirely new data set that it's never seen before will give a true indication of how well that model fits the data. And this could be a final model that we share with people across the organization, but it could push us back to ask more questions. Say, for example, we do a clustering algorithm to look at different buckets of our customers. Once we've created those, we might want to say, OK, I want to predict my revenue from these different buckets. So again, an iterative process. Finally, we get something that we're ready to visualize, communicate, and share with different business users. And again, at this stage, could bring us back to the beginning and think of more data that we might want to use and bring in to enrich our understanding and get us closer to the end goal of insight. Now, I appreciate now this is getting quite a busy slide, and this is going to be something I'm going to refer back to throughout the session. So I've made a nice little simplified one that kind of summarizes each of the steps. But I wanted to show the busy one as well, so you can see all the different intricate steps that make up what I refer to as the data science flow. So, on to today's topic. We've had a look at the theory. I want to introduce you to today's topic of saving the world. So the next 45 minutes or so, I want to take you all on a journey of real-world data analysis, all along a single theme. So there's going to be multiple questions that come up along the way. Just like we all deal with on a daily basis, we need to adapt, change, and keep moving to the end goal, which is the insight. So the data sets might be somewhat different to what you use on a daily basis, but what I really want you to focus on is the integration between Tableau and Python and how it could be adapted maybe to answer some of your own business questions. So why saving the world? So I wanted to explore something that I'm personally passionate about, something I think we're all becoming a lot more aware of as well. There's been lots of protests in London recently around the climate change emergencies. It's something that in Berlin, the younger generation are really getting behind as well. And even if we look at the recent European Parliament elections, we can see that it's something that us as a continent are starting to wake up to and putting people in power that have environmental concerns at the forefront of their agenda. So I think it's something we're all quite aware of. So why me? Why is this something I'm interested in? So I kept my introduction at the beginning quite brief, not too much personally, but I love nature and I've been really lucky to see some amazing places around the world. I studied a geography degree, I got my master's in geographical information systems, so environmental issues is something that's really close to my heart, and I thought if I can raise awareness for something while showing you guys some awesome Tableau integration, then I think that's a win-win. Okay. Back to our data science flow. We need to start with a question, and the theme of today is saving the world. So one of the biggest threats to our environment right now is the rise in CO2 emissions. So I want to see, using Tableau and Python, can I define what are the predictors of national CO2 emissions? So we have our question. We now need to find our data. We need to find data, collect, and process that. But where do we even start with something like this? Well, I turn to my good friend Google. So I had to do some research to decide what variables to even think about included in my model, and this is what I found. So I found lots of academic, World Economic Forum information, scholar articles, and academic papers. I found lots of really good information from charities. They do a lot of work in this space and raise awareness, and something really interesting was the WWF survey. You can fill in information about your lifestyle, and it tells you what a terrible person you are and what huge CO2 emissions you produce. So I had an idea of what I wanted to include in the model, but now I had to go and get the data. So back we go to Google. I found information from Our World in Data was a really great source. I found things from Kaggle, which is a data science website, posts data sets and projects. Wikipedia, of course, and then specific specified websites as well. So I had all of this information, and how can I even go about making sense of all of this, aggregating it to the right level, and bringing it together? Any guesses? Tableau Prep. So the aim of today's session, I'm not going to drill down too much into my prep flow, but this is just a quick snapshot of it. There's been some great sessions this week at TC if you're interested in finding more about Tableau Prep and the different things you can do in it. But I essentially took my 11 data sets. So I found a data set on CO2 emissions per country, and then 10 different variables that I hypothesized to be correlated. So I removed unnecessary fields, cleaned my messy data, and joined all these data sets together. But the best thing about it is that there's now an auditable trail that tells anyone exactly what I did to go from point A to B, from this point of 11 separate messy data sources through each stage of the process to get to the end result. So any business user, or even yourselves, if you want to look at my content after the session, you can look and see what I did to get to each point. So the resulting data set gave me data for 141 countries, the CO2 emissions, and then the 10 variables that I hypothesized to be correlated. And these are the variables here. So I was looking at things like meat consumption, registered vehicles per country, and electrical consumption as well. So these are the different 10 things that I thought were relevant. Now, before we jump into Tableau and take a look at that data, I want to just recap how the integration works. So like I said, I'm not going to dive too much into this at this stage, but I realized there might be some of you in the room that came to Konstantin's great session yesterday, so you've had to play around with the integration. Some of you might have set it up yourselves, but equally, some of you, this might be your first touch point with it. So I want to take a little bit of time, get everyone's knowledge in the same level, hopefully without overboarding you with information. So what's happening under the hood when we connect to Tappi? So the first thing you're going to see me do is create a calculated field that contains a script function. In that script function contains my Python code and the data that I want to send with it. Then when I drag and drop that into the view, what's happening is we send that code and the data along with it to the underlying Python instance, the Tappi instance. The code's run, it creates a list that's then returned back to Tableau, where we display it as a table calculation. So this is really important too, because if you're familiar with table calculations, we can change how they're computed. And this has a big impact on how we send your code to the underlying data source, which I'll show you in a little bit. OK, quick review of a script function. So the first thing we need to define is what response we're expecting back from Tappi. So even at this stage, we need to know what the response type is. And you have 4 options. It can be a Boolean, a true or a false, integer, a whole number, real if you're expecting a decimal response, and string if you're expecting a string response. Then we have the whole chunk of text in gray. Now this example I'm showing here is for sentiment analysis. So I import the libraries, write my code, but there's something a little bit special about this bit of code. We have a special reserved character. There's underscore argument 1. So anywhere you want to input data within your script, you use these placeholders, and then you list the value down at the bottom. So in this example, I'm defining a variable text, and that text is going to be a column in my data called comment, which is just listed at the bottom. If you have multiple arguments, really simple, it's just underscore arg2, 3, 4, and then it's a comma-separated list of the variables at the end. OK, so now we've got to grips with the theory. Let's take a look at that in action. So first, we're going to explore our data visually. Then I'm going to do a simple example where we call out to Tappi. And then I'm going to perform a regression function to see if we can accurately predict CO2 based on my variables. OK, so now we're in Tableau Desktop. And the first thing I always start doing when looking at a new data set is check how many records are we working with. So remember, we said 141 records. So I know that each row in my data set is a country. And we can have a look at how this is distributed. We create a map. And we can see we have quite a good global distribution of different countries I'm using in my analysis. And we can even take a quick peek at the CO2 levels for each of those countries. And even at this stage, we can see that we start to have a couple of outliers. So China, probably producing the most CO2, closely followed by the US, and then probably India, Russia following not too far behind that. So we know what our initial data looks like. Let's take a look at integrating with Tappi. So the first thing we need to do is establish a connection between the desktop machine I'm using now and the Tappi instance. So if we go to Settings and Performance, we want to manage external service connection. And then we define we're connecting to Tappi, and then just have to put in some information, so the IP address where your Tappi server is running and what port that's going to be listening on. If we test the connection, we get a lovely little successfully connected to the external service. So now I know that Tableau and Tappi can talk to one another. And the example I'm going to start with, so if anyone's ever done any online coding tutorial or introductory to script writing, is we write hello world, say hello to the world. So I'm going to try and replicate that now with Tableau. If I look at the underlying data, you can see I've got a column here that just contains the string hello world. And then I've created a really simple script function, which at first we're defining what response we're getting back, remember? So we're expecting a string. Then I'm defining an argument, P, is underscore argument 1, which actually is the column within the data I just pointed out. And then I'm returning that column. So super simple. And when I bring that into the view, drop it onto label, we get some lovely hello world labels. So that's great, but right now you just kind of have to trust that that's what's happening. I could have just pulled in a dimension, the same dimension. And I am pretty trustworthy, but I kind of want to prove it to you guys as well. So this is a really good tip you can use when troubleshooting your Python code within Tableau as well. We've created an amended script function. And what we have here, so it's the same, still defining a string, defining our argument. But now I've dropped in a couple of print statements. So first I want to print a bunch of stars. And then I want to print P, which in this case is our hello world string text. What happens now, if I bring this into the view instead of the one we just had, what we'll see is not much changes in the view itself. But if I jump over to the machine where Tappi is running, what you can see now is that it's printed in the command line where Tappi is running the print statements that I told it to. So we have the stars along the top, and then we have 141 instances of hello world, because that's what's being passed back and forth. So this is a really nice way in which you can check if you're having errors, you can figure out which line it's in reference to, and also what information is being passed backwards and forwards. So that's a nice simple example, but at the minute we only have one level of detail in our view. I only have the country dimension. But let's see what happens if I bring in a second. So I have which continent each of these countries relate to. So we have four continents: Africa, Americas, Europe, and other. So now it becomes really important how our table calculation is computed. So if we take a look, if anyone's familiar with table calculations, when we edit like this, any of the ticked dimensions is what we're addressing, and the ones that aren't ticked are how we're partitioning. So in this case, we're addressing country, partitioning by continent, and what that means in Tappi world is for every partition in your data, we're going to make a separate call to Tappi. In this case, 4 continents, we make 4 separate calls, passing each bundle of data in turn, which we can see in here. So see now it's different. We no longer have 141 of these hello worlds. We have a bunch after each line of stars. So in this instance, because it's really simple, it doesn't really matter too much. But you can imagine a situation where if you have a dimension that has lots and lots of values, say hundreds or thousands of values in a dimension, and you're partitioning your table calculation by that, it's going to be making hundreds and thousands of calls to the Tappi server and that's going to really affect your performance. So most of the time, it makes sense to have all the options ticked in here, because then you're just going to make one single call to the server, send all the data, the script will process, and you get one list back with all the variables. Now, of course, there are instances where you might want to utilize how table calcs work to be able to send separate packages, but most of the time, if you're running into performance issues, just check how you're computing your table calculation, address all the fields, and you should be good. Okay, that's our top tips for the day. Now back to our challenge of saving the world. Let's take a look at some of our data. So we know that we're looking at CO2 emissions for each of our countries. And then we might want to look at one of our variables, maybe meat consumption per country. And we can start to see a couple of outliers. We have China up here, with creating the most CO2. The US over on the far right, so producing quite a lot of CO2, consuming a lot of meat. And then an interesting one, India. So that has a relatively high CO2 emissions, but relatively low meat consumption. So we know there must be other variables in play that are contributing to that. We could even come in, maybe create a quick density view to start to see a couple of different hotspots within the data set. So this is quite interesting, but remember, we shouldn't be doing this at this stage. We need to partition our data to train and test. So I need to do a 3-way split to ensure that there's no bias, because if I test my model on the same data that I've been training it on and analyzing, then it'll create bias. So I'm going to take a 3-way split approach, take the whole data set, split it into training and testing, and just train and validate on one single data source. So the way in which I did that in my data set, I have a column where I just randomly generated test or train values. And if we look at how that splits out over the whole data set, you can see we have sort of 99 in our train, 42 in our test. And if we look at what that is as a % of total, we can see we've gone for a sort of 70-30 split between our training and testing. So that's great. And we're now at the second stage of our data science flow. We've collected our data, we've cleaned it up, we've split our data into train and test, and now we want to apply our model. So in this case, we're going to do some multiple regression because we want to predict the outcome of one variable based on multiple other variables. So back to analyzing our data. So this is the same viz with CO2 versus meat consumption. Remember, we have to filter out and just keep our training data set at this stage. And we can see they do seem quite correlated, but I'd really like to be more specific and scientific about how I'm going about this. So what I want to do is figure out the p-value. So the p-value is a statistical measure which explains the extent to which the variance in our 8 variables explain the significance of the relationship between the 2 variables. So it's a value between 0 and 1. The smaller the number, the stronger the evidence that they're correlated. And a good confidence interval that I'm going to use is 0.05. So if the p-value is less than that, I'm going to say that these are correlated and I want to take this through to my model. So in Tableau, it's really easy. We don't even have to write a calculation for that, because as soon as we bring in our trend line, we get given that value as part of the tooltip. So I can see now the correlation between CO2 and meat consumption is significant because my p-value is 0.03. And this is something that I can repeat for all the different variables in my data set. So I can see here's the one we just looked at, 0.03 for meat consumption. Registered vehicles per country is pretty significant, same with number of landlines. And in fact, there was only 2 variables that weren't. So tree canopy cover per country had a value of 0.6, so I'm going to scrap that. I don't want to use it in my model because it's not significant enough. Same with air carrier passengers per country. So even at this stage, Tableau is helping me understand my data in a visual way to decide what I want to put in the end model. And we're going forward with the four separate variables. Okay, onto the regression. So in this view now, I have my CO2 per country. So each bar is a country. Remember, so now we're ready to test. So we just need to pull in the test filter and then keep only our test data. But we have to do this in a bit of a special way, because if I just pull in the same dimension that I did before, we're removing all of the training data from the view when we know that the model needs that to run. So a trick that we can do is create a table calculation, which is essentially doing the same thing, but wrapping it in a lookup and checking if it's significant to test. It pushes that filter down your order of operations, meaning that it'll still get sent with your model to Tappi. The model will still run, but we just don't see it in the view, because table calculations are the very last thing that happen in your order of operations. Again, if what I just said made no sense to you, there's a great session running this week on order of operations. It'll help you understand that a little bit more. So what we can do, we bring that into our filter. Keep true, we only want our test values, and now we have our leftover test countries. But we can see that China's really skewing our view here. All the other bars are so teeny tiny. So what I'm going to do, I'm just going to edit this axis, change it to logarithmic and symmetric. So we don't just want the positive values of the log, we want negatives as well. And then we can see our data distributed a bit nicer. Okay, so onto our model. If I open and show you the code that I've already created. Now for today's session, I'm not going to go through the code line by line. I think you'll probably thank me for that after a data night out and a few too many beers in the beer garden. But I'm going to give you a quick overview of like the kind of structure. So first of all, I'm expecting a real response, so decimal. Then we import the different libraries we want to use. And then we create a data frame. So data frame is really helpful because it's going to take all of those variables we had and put them into a table or a matrix. Then we apply our model to the different variables, create our result, which is the outcome of the model times by the variable, and then return that to Tableau. And then we have all of our variables that we want to use listed in the bottom after the code. All of these examples will be available after TC as well. You'll be able to go and download the workbooks and see the exact code. I saw a few people taking pictures, so you're welcome to do so, but you will get the actual content as well. So now we're ready to bring that into the view. And it's quite fast, and we've now predicted our CO2 for each of these countries. As we're working with CO2, I'm just going to change the bars into a different shape. We're going to use a lovely little CO2 cloud, maybe make them a little bit bigger so you can all see. And then what I want to do, I want to lay one on top of the other so we can compare. So I'm just going to create a dual axis. And what we can see here, it looks like my model hasn't really worked that well because they're so disparate. But the thing to remember about dual axis is that you might want to synchronize the axis. So at the minute, we're using 2 different axes to look at the same data, which is skewing our view of it a little bit. So when I synchronize the axes, we can see now that it follows a much better pattern, or much more similar pattern. And I can hide this header because it's just showing the same as the one on the left. So at first glance, we can see that some values are over-predicted, some are under-predicted, but generally it follows the same flow. But I want to be a bit more scientific about this, and I want to know the exact values, so I can quickly create a calculation on the fly to look at my difference. And we can bring that into the view. And so now we see visually on our logarithmic axis the flow and how the pattern is similar to how we're predicting, but also we get the absolute values as well. So I think it's done quite well, but again, I want to be a bit more specific about this. I'd really like to see the R squared. So the R squared is a statistical measure that allows me to explain the extent to which the variance in our 8 variables explains the variance in CO2. And again, this is something that I don't have to call out to Python to do. We can take advantage of Tableau's window calculations, window sum, window average, to recreate the R squared formula that we would want to run against the data. And for this, I'm not going to bring it into the view, but I'm going to bring it onto tooltip. So this is a really nice way, particularly if you're wanting to encourage more people to get involved in this conversation around data science and understand a little bit more about these things. You can utilize tooltips to add this contextual information. So I'm going to add in my difference that we just calculated, and also the R squared. Maybe make this stand out a little bit. And now when we hover over, it says in plain English something that everyone can understand. So we can see that 72% of the variability in the data is explained by our model. So I know that 26% is affected by something that I haven't considered and haven't thought to bring into place. But having it like this in a nice, friendly, readable form, as opposed to just having R squared equals, which will only mean something to a small subset of people, is a nice way to encourage more people to understand the work that you're doing. So this is quite interesting, but it's kind of just showing me the state of play, how things are today, right? What I'd be interested in is looking at how things are predicted to change in the future. And not only that, but how might things look if we change some of our behavior? So going through this process, I produced a model, but it's forced me back a step because I've got more questions now that I have to change and adapt to run against my data. So what if we changed our behavior? So this is a pre-built out visualization that's very similar to the one we just saw. Now I have all of my countries in the view and a new predicted CO2 variable. This is based on a couple of new conditions. So I went online and looked at future population and found out values for how certain elements are set to predict in the future. So say, for example, future urbanization, I can create a new calculation that takes my original one from the underlying data source. I saw that it's predicted to increase by 1%, so I can make a new measure on the fly to use in my model. And now there's certain things that are out of our control. We can't really control how urbanization is going to work, right? But there are certain things that we can have an impact on. Say, for example, number of vehicles in use. So what I've done here is taken the original value, the original variable, times it by what it's predicted to increase by, in this case 5%, and then applied something that I've called a reduction ratio. So you can see that the text is purple, so that means we're using a parameter. So we can parameterize values within our variables that can be input by an end user. If I jump to the prediction code that I'm using here, you can see the code is very similar to before, but now with a couple of amendments. So we're still expecting a real response, using the same models, but now we create 2 separate data frames. So what's cool about this is that we create our original one like before, looking at our original values, and this becomes our training data set, but we can use all of our countries now. And then we create a second data frame using these new variables that I just created based on the predicted future state. So now our training data set is all countries' state of how it is today, listed here. And then our test data set is this fictitious one that we're allowing people to do their own what-if analysis on, which is pretty neat. What this means is that we can have a parameter in the view like here, our reduction ratio, and I can say, so if we look at how things are today, if we make no improvements to our behavior, there's going to be 846 million tons more CO2 in the atmosphere. But say if we take the initiative and reduce things that are in our power by 20%, our model reruns, and it's going to repredict. So a 20% improvement in some of the variables that are in our power will result in 5,000 million tons less CO2 in the atmosphere every year. So this is a nice way in which you can, again, as well as having friendly things in the tooltip to encourage people to understand what's happening, give them the opportunity to get involved themselves in a nice, easy to do way. And you can imagine a situation if we were to publish this up like to Tableau server, just like this. You can add some more contextual information, maybe add an information button, tell them which variables you're using, what model you're using, and how accurate it is. So if you turn around and say to a business user, this model predicts 74% of the variability, but there's 26%, we're not sure where that's coming from, and they see the list of the 8 variables, they'll immediately know, oh, if something else you might want to include. So having more people involved in a conversation can only be a good thing. And they can also do their own what-if analysis. So if they're feeling a little ambitious and say, I think I can improve my conditions by 30%, they can do their own what-if analysis on the fly. And the model will rerun from Tableau server in the same way that it did in Tableau desktop. And we see that a 30% improvement will have almost 7.5 million tons CO2 less in the atmosphere. You can even check that on a country basis. Let's take a look at, we're in Germany today. And we can see that will result in Germany in almost 200 million tons less CO2. So this is a nice way in which you can get more people involved and playing around with your powerful models. They don't need to know the code that's behind the endpoint. They can just take this and intuitively understand what's happening and ask their own questions. Okay, so we've gone through one full iteration of our model. We started with a question. We found and processed our data, applied our model, and iterated until we had a final solution. And that's something we can share with the business so they can do their own what-if analysis. But this has got me thinking. So we've explored how our own actions can impact CO2 emissions. But there's another side of this topic too. What about how our CO2 emissions and climate change are impacting the environment around us? So going through this process has made me think of another avenue to explore, and I'm going to need some new data for that and do some more research. And this is what I found from my research. So I'm sure everyone will be familiar with images just like this. Temperatures in the Arctic are actually increasing twice as fast as the global average. And this affects polar bears' ability to hunt food because of the diminishing sea ice. Another horrific example of the declining sea ice is that tens of thousands of Pacific walruses have started to assemble en masse on shorelines to rest because there's no sea ice for them to rest in. And this is really dangerous because they can get easily spooked and cause deadly stampedes. But it's not just animals that are impacted by rising carbon emissions. It's also the greatest threat to global coral reefs. Temperature rises are resulting in mass coral bleaching and also outbreaks of infectious diseases. In fact, there are more than 27,000 species globally that are threatened with extinction. And according to the WWF, global warming is likely to be the greatest cause of species extinction this century. Just 1.5 degrees increase can result in 20 to 30% are at risk, and a more than 2-degree increase means that most ecosystems will struggle to adapt. So, knowing that the predicted increase in global warming will have a dramatic impact on global biodiversity, I want to use this data to investigate, can we predict threatened species? So now we're back at stage 1. We need to find data to answer our question. So again, I used Tableau Prep to combine 2 different data sets that I found. So the first one being the IUCN Red List of global species, which gives you attributes about a species and flags up whether they're endangered or not. And also an international trade species database. So this looks at where species are traded and for what purposes between different countries. So let's jump right in and take a look at that in Tableau. So again, we have our total data set. So I want to check how many rows we're working with. And in this case, we have 130 rows, which relates to each individual species. So 1 row is a species, and we have 130 species to look at. Again, I split my data into train and test randomly. And this breaks down into 105 for my train, 25 for the test, which looks at sort of more of an 80 to 20 split. in this data set. So let's take a look at some of the variables that I looked at. So first I'll look at the continuous ones. So in this visualization, the top row are species that are not endangered, and the bottom row is species that are endangered. And we look at a number of variables about that species and its habitat. So the size of the area where it's found, the population of the country it's being imported to from the trading database, and then lots of information about its origin as well. But I think the most striking thing about this is there's not really much insight we can pick from this. There's not really that much of a pattern between endangered or not endangered species, maybe a few things here and there, but it's very difficult for us to see with our eyes any key insights. Let's take a look at discrete correlations. So now the way to interpret this visualization, so red represents endangered species, green non-endangered, and what we're looking at, each column is a different attribute or variable, and what we're looking for is the slope of the line. So animals that are traded for scientific purposes doesn't really make a difference whether they're endangered or not, because the line is quite horizontal. If we compare that to hunting trophies, we can see that animals that aren't endangered are much more likely to be used for hunting trophies than ones that are endangered, which surprised me at first, but makes sense if you think about it. It's because if an animal is endangered, there's going to be much stronger restrictions on whether they're allowed to be hunted in the first place and then the trade of them after that. So we can see that some variables have a stronger impact than others. And then habitat, this one on the far right, we're looking at the difference between a species that's in a marine habitat, a freshwater habitat, or land habitat. And this one's quite striking because 80% of species in freshwater in our data set are endangered. Another thing to point out here is that I already filtered out to just look at the training data set, similar to how we did before. But there's another filter there too as well. I filtered out on the different class. So when I first started doing this analysis, I got lots of data about all different species. But then as I was going through the process, I was getting strange results. And then I realized it's because I was trying to compare the extinction of mammals, like rhinos, elephants, to amphibians and reptiles, which will have much different impacts on their environment. So in Tableau, I was able to quickly make a data source filter to filter out all that information. I didn't have to go back a stage, collect new data, reprep my flow. I was able to just quickly drag in a dimension filter and carry on with my analysis. So now we've collected our data, we've split our data into train and test, and now we need to choose our model. And this time we're going to be looking at a logistic regression to try and predict the binary outcome of a species being endangered or not based on our different variables. So what I've built out in the view here, so we have each row is referring to a different species, a different animal, and then a little paw. So if the paw's green, that animal's safe, it's not endangered, but a red paw signifies if the animal's endangered according to the original data source. And then we can see here we've used our same trick again to filter out to our test data using a table calculation. So let's take a look at our model. In this case, what we're doing, we're expecting an integer response because it's going to be either a 1 or a 0, endangered or not. And then we're importing our libraries that we're going to use, pandas and sklearn. Then we're building our data frame like before with all our variables. We define here, we hard code which model we want to use. So I said I'm going to use logistic regression, so I define that here. Then I fit my model to my training data set, and I predict my model against my test data set. And then we return our result and have all the variables listed at the end. So let's bring that into the view. So what we can see here, excuse me, is that it's predicted that most of our species aren't endangered. According to my lovely new model, the world is very rosy, nothing's wrong, except when we get to this whale. This poor whale is endangered, but everyone else is fine. Well, if we compare that to our column on the left, we know that that's not correct. But we can be more scientific about this as well. Again, utilizing Tableau table calculations, we can say, ignoring our test data set, if our predicted status is the same as the sum of our test data set, then give it 1, else 0. And by taking the window average of that, we get the percentage of times that my model is correct. And again, we can bring that in and just look at it on our tooltip. And what we see that we're correct 48% of the time, which isn't really that good. So I know from this that the logistic regression model I'm trying to use doesn't really fit my data. The data that I'm trying to use and put in there doesn't make sense. So I need to use a different model. So I could go back, I could rewrite my code and test with another model. But a better way to do it would be to make this interaction flexible. So in this sheet that we're looking at here, it's going to be the same as the one we just saw. So the first column is related to our actuals. The second one is our prediction. And then I've got two more columns. One, whether it was accurate or not, and then the percentage accuracy. So using my logistic regression model, I'm 48% accurate. But a nice flexible way in which you can play around using different models is to utilize, like we saw before, this idea of parameters. So now, again, same as before, we're pulling in we're expecting an integer, but now we're importing multiple different models. So we have logistic regression like before, and 3 others as well. We're building the same data frame, training and testing our model, but now when we get to before, where we'd hard-coded that we were looking at logistic regression, we now have an extra argument 16. And what's great about this is we can just list it at the very end of our variables, and it can input this string value to play in and out different models. So with logistic regression, we saw we didn't have a very good accuracy. But if I change my model by selecting from a drop-down, it runs this powerful algorithm in the background, so I don't have to rewrite anything. And we can now say we have 72% accuracy this time that it's run, which is much better. And again, this is something that we can publish up to Tableau server and share it with other users. So again, here is where I've added a bit more contextual information, some nice descriptive headers to explain to someone what's happening. And they can come in here and choose on their own a model to run against the data. Even adding extra little touches to make it more visual to the end user. They can come and see which species were predicted correct or not. So maybe not so interesting where we get the model right, but where we get it wrong. So for example, we have a false positive here for fishing cat. The fishing cat is predicted to be fine, but we really know it's not. Same with others. If we scroll down, the sand cat is another one. So immediately, even just me going through this, I can spot there's a bit of a trend between when we get cats, predict cats right or wrong. We've got a false positive for tiger, so we think everything's fine, but actually it's not. So having extra visual stimulants can sometimes take you that extra push to spot insights in the data as well. And again, finally, this pushes us to the last stage of our data science flow. We have something we want to visualize and share with the organization. And then business users can use this to answer better questions about the business and be more informed when they're making decisions. So far, we've looked at individual examples of different models that we can run within a calculated field. And we've also seen that there are many iterations that contribute to these final models that we use in the business. And often there might even be multiple people working on this same thing. So maintaining code in a calculated field might not be the ideal way to go about that. And this is where being able to call out to an externally hosted model is really helpful. So say, for example, we have a team of data scientists contributing to the code that we just used to try and identify whether a species is endangered or not. So they can write the Python code of different classification methods and all collaborate and commit their code to the final Python script. What we're able to do by running a command line in the Tableau server environment is to, Tappi environment, is to deploy this model into the environment ready to be called and utilized against our data in Tableau. This model can then be called in a Tableau calculated field, and all it takes to run this model is a single line of code within the calculation. And regardless of the complexity behind the endpoint. So this is really powerful because it means you can improve and update the model behind the scenes, and it doesn't need to change. You don't need to make any changes in the calculated field in Tableau. It just works. And further to that point, this is really great for dashboard authors as well, because they don't need to know about the complexity and things behind the scene. They simply drag and drop the pill like any other in Tableau. So, time for a moment of reflection. If we think about what we've accomplished in the last hour, we pulled together many disparate data sources in Tableau Prep. We visually investigated in desktop and called out to Python to run advanced algorithms that support our findings in a way that wouldn't otherwise be possible. And finally, we shared that on Tableau server so that other users can share and collaborate and find their own insight by smart algorithms. So exposing data science in this way to people across the organization is a really great way to get them involved and introduce them to the power of statistical models and begin to understand the outputs of them without having to know how to generate them for themselves. If we think back over the goals that we defined at the beginning, hopefully now you feel a little more comfortable in how you can use Tableau and the external service integration, and that it's easier than you think to implement. And once the initial implementation is set up, this can be scaled to many users so that they can take advantage of the extensibility of Python and the flexibility of Tableau. So, what next? As I mentioned, you'll get all the content that I've gone through today, so feel free to take it, copy, paste, adapt it to fit your own data sources, have a play around. And from a more environmental perspective, we can have big changes if we all think globally and make changes to things that are within our power. I think we could all make a big difference. With that, there's some sessions that I've recommended. I touched on quite a few different advanced topics as we went through today that unfortunately I didn't have time to delve into. These sessions ran yesterday, but they're all going to be available on the Tableau website with recordings and content. So if there's any certain elements that didn't quite make sense as I was talking through, check out these sessions, and I think they'll be really helpful. With that, I'm not sure if we have time for Q&A. We got time? We've got 7 minutes worth of questions. What I would encourage you guys to do before we jump to that is just take a minute to fill in the session survey. I'll give you a minute to do that, and then we can have 5 minutes of questions towards the end. This is the first time I've built the session for this conference, so if there's any recommendations that you have, things that you liked about it, things that you would like to see improved, please let me know, and I can iterate on it and make it better next time. But thank you very much for your time. Like I said, we'll give you 2 minutes for the survey, and then do questions. Thank you very much.